Okay, so Chapter 15 is on PKI, public key encryption, and some of the encryption protocols. We've looked at how to, how these work, but in reality, from a network standpoint, we want to be able to encrypt this stuff as it's sent over a network. That's really where we're focusing on. Basically, for a secure network, here's what you need to think about. The data should be encrypted at all points except when it's actually on the screen. The data ought to be encrypted at rest when it's on the hard drive. It ought to be encrypted in transit, which is when it's sent over a network. So this is where some of these protocols come into play. MD5 is fine for hash. You shouldn't use it for much else. The collision is, and I'll dig and find the actual statistic to tell y'all, because it is something that is possible, but it's still pretty improbable, I think. One of y'all can Google it and probably find it right away. All right, so what we're going to talk about in this one, we're going to talk about PKI, the concepts of private and public keys, and then something called the web of trust. It's frightening that a lot of this stuff like SSL and some others rely on trust. They rely on that somebody is trustworthy, and the question really becomes, do you trust anybody? From a security standpoint, the answer usually is don't trust anyone for any reason. But some of these protocols require a trust model in order to work. We're going to talk about some of the security protocols. We'll talk about SSL and TLS, SSH. Then we'll talk about the VPN ones, point-to-point protocol, layer 2 tunneling protocol, and then IPsec. All right, so public key infrastructure refers to basically the encryption system in its entirety. The hardware, the software, the policies, the procedures, and the people to create and revoke digital certificates. This is used everywhere, digital commerce, email, connections to remote computer. How many of you bank online? Probably everybody in the room. It's like the other day I needed to write a check and I had to find a checkbook. I knew I had one, but I haven't written checks in forever. So this includes the users, the client servers, the computers, and the encryption itself. An example of public key usage would be a certificate from a web server for an e-commerce site. An example of private key would be when a user needs to encrypt the digital signature of an email. Again, I encrypt it, you encrypt it, and then for me to read it, I got to have my private key. All right, so a certificate is a signed electronic document that binds a public key with user identity. The most common of this is the X509 certificates. These are used for websites, they're used for email, they can be used for local encryption. An SSL certificate, there are a lot of different types. There's a domain validation, organization validation, and extended validation. We won't really have to get into those, but know there's some different types. And it's based on who you trust to give you that certificate. The certificate formats, there is a basic encoding rule, there's distinguished encoding rules, there's lots of different ones. But basically, the players in this are the CAs, the certificate authority. And one of those is an RA, the registration authority. This is who verifies requests for certificates. An RA might be used if the organization deals with several CAs. VeriSign, y'all have all heard the term VeriSign. VeriSign is one of these. And this is where web of trust comes in. For you to get a VeriSign certificate to prove who you are, when you get upper level certificates especially, they need to verify you by actually going to and meeting you, or they should, to ensure that you are actually who you say you are. Because that piece of trust for the whole system is that your RA or CA did their job to verify that you are who you say you are. Yes, some of this is done by mail, and that's kind of a problem because if I send you a driver's license or a passport picture by the mail, do you really know if it's me? It also works on the idea of a certificate revocation list. If I assign you a key, I'm a CA and I give you a key, and that key gets compromised. Somebody hacks your server. For this system to work, you've got to let me know immediately somebody hacked your server, and then I need to put you on the CRL. I need to revoke your certificate so that it's no longer valid. Online Certificate Status Protocol contains less information than a CRL and does basically the same thing. It's not encrypted. It's supposed to be faster. We still use CRLs, though. And the key escrow is when a key is held by a third party. An example of this, at the root of, at the root of VeriSign, the upper level of all of VeriSign, there is an RA key to assign all of the keys to all of the CAs that makes the entire VeriSign work, which is what makes SSL on the web work. Because of the extreme importance of that, they use escrow for that key. In fact, they use a very multiple piece of escrow for that key. That key is only used to generate keys on a computer that is not connected to a network. And that key itself only exists in two separate pieces that are kept in two separate safety deposit boxes in two different countries. So it takes two people to get those together, to bring them together to that one server that is the root of everything. All right, so single-sided certificates is when the server validates itself to the recipient, such as a user who accesses the website. Dual-sided is the server and the user both validate their identities. This works well with a limited amount of computers and sessions, but you got to have a certificate for everybody. The chain is the list of certificates that's the chain of trust concept. And then again, the web of trust. This is where I trust someone that that key is valid. For VeriSign, or for others to work, for PGP, it has to be that I trust the model that's signing that certificate. All right, so there are lots of different certificate protocols. One of the first ones that you'll talk about is SMIME. This was used to send internet mail. Basically, it is an extension to ensure that mail is who it is. We talked about the CIA triad. The integrity piece is making sure that that message is what it's supposed to be. Authenticity, that's non-repudiation. That's so that I can prove you're the one that sent it. SSL and TLS, these are used on web pages. They can be used for other things. Email, VoIP can be SSL or TLS encrypted. They rely on public key infrastructure to validate those certificates. That being VeriSign or one of those companies like that. Secure shell is the answer to the fact that Telnet is a insecure protocol. How many of you know what Telnet is? Anybody else? All right, you're going to learn a lot about Telnet when you take the Cisco class. Telnet is a way that you used to remotely log into Linux and Unix servers. Basically, you would log in, and it's non-graphical. You get a prompt like you're on that server. My server, for example, in here, the Linux server for this room I do imaging with is called Beta. If I SSH to beta. Whatever I named this domain, I don't even remember it right now. I can log in, and I'll get a prompt like I'm on the server on that computer. Well, Telnet does that in the clear. It sends unencrypted passwords, very much like FTP. Y'all remember when I had y'all go through the little Wireshark file and find the password? You could do that with Telnet just as easy. Instead of looking for port 23, you're looking for port 21? Or am I backwards? Don't quote me on that. One of y'all check it. One of them's Telnet and one of them's FTP, and I never remember which is which. SSH is the answer to that. It uses encryption to make sure that it's an encrypted conversation so that your data is not sent in the clear. Telnet's 23, so FTP is 21. Right, SSH is right in the middle, port 22. All right, so another big use for Encryption and Protocols is for VPNs. Lots of places now have workforce that needs to get to their servers from outside. You might be working at home, or you might be part of a Salesforce team, and you need that access from wherever you are. And one way we do that is with a VPN, a virtual private network. Remember, a VPN is a connection over the internet that makes a private connection from where you are into my server. If I VPN into this lab, for example, I can VPN into this lab from the house, and it'll look like I am sitting in this room. I will get a 192.168.1. whatever address. My computer at home is part of this network then. Well, okay, for that to be secure, I need to encrypt that data because I'm sending it over a public network. I don't know who's reading that data on the internet between my house and here. So one way is point-to-point tunneling protocol. Point-to-point uses what's called a PPP packet. And those are unencrypted, that's wrapped around an encrypted protocol. It is widely thought you should not use PPTP anymore because it's not as secure as it used to be. Layer 2 tunneling protocol is still used. All right, OSI layer, layer 2, so what am I talking about? I'm going to keep going till y'all get these. Data link layer, all right, so what kind of addressing are we looking at data link? Not IP, but .0.0.0F, what is that? Come on, y'all. I know, I'm hearing you, but I'm making them say it. You're not in class. MAC addresses, thank you. Layer 2 works on MAC addresses. So here, we're making a network with MAC addresses. What does that also kind of maybe tell you? If I'm looking at a MAC address, not a TCP IP address, what does that mean? It's okay if you don't get this one, but I'll explain it. Yes. A layer 2 tunneling protocol sends by MAC, so it doesn't have to be TCP IP. If I am an all Apple place and I'm using old Apple servers and I'm using AFS protocol, Apple's protocol. Now, it doesn't really exist anymore because everything's TCP IP, but for purposes here, I'm going to say we're doing it for whatever reason. L2TP just encapsulates the packets from layer 2 into a packet and sends them out on the network. So any protocol will work at this layer. Anything that broadcasts will work with a layer 2 protocol because a broadcast packet will get encapsulated and sent out. All right, other ones are IPsec. IPsec authenticates and encrypts the packets, securing communications between two devices out on a network. IPsec, unlike layer 2 protocol, does only IP addresses. Pros and cons to both. Layer 2, if I need to send something non-IP is great. There's a lot of extra chatter and bandwidth used because maybe I don't need broadcast packets to go out. Maybe I only need IP traffic. IPsec comes into play for that. IPsec has three pieces, an SA, an AH, and an ESP. SH is the authentication. The AH is the header. That is basically to check the authentication. And then again, the way it works is called encapsulation. And all you really need to know about encapsulation is that is taking something and putting something around it. The way this works is we take IP traffic, IP packets, and we encapsulate them into our secure packet. They get transmitted out on the internet. They get to the other router. It pulls that encapsulation off and puts it on the network. So if we hash that properly with a CRC, and I get an answer A over here and it's answer A over there, it matches, theoretically, that data got sent, encapsulated, de-encapsulated, and put on the network in the same state that it was when it left me. And there are two types of that, transport and tunnel. Transport and tunnel, since it didn't get into them, transport is basically building the connection as needed. A tunnel keeps the connection open all the time. If I VPN tunnel into here and leave it, that connection is open. It doesn't have to be one way, by the way. You can also set the tunnel where traffic can go two ways. If I were, for example, to go home and tunnel into the network here, and I were to do a layer 2 tunnel protocol and leave it open, and let traffic from here on the firewall flow back and forth both ways, you could nmap this network, and you would see my computer at home. You would find it, you'd see its IP address and its MAC address just like it were here. All right, so this one's kind of short. There's 5 true false and 5 multiple choice. The labs will let you set up a little VPN to see how it works. It's very easy to do with Windows. Windows has all the built-in stuff to do it. Pros and cons, not getting into it because it's not in this class, but lots of places use Cisco for this. And Cisco's great, but it requires Cisco's proprietary equipment, and it uses their proprietary protocols. They're a little faster than the standard stuff you can get without it. But, again, not a lot of people want to pay that money. Cisco's very good at what it does, but it's very expensive. Pros and cons as to how many users you're going to have. If you're a small network and you're only going to have 1 or 2 users logging in remotely, you're probably not going to buy a $4,000 VPN concentrator, you know, for your users. If you're a big place like this with a Cisco shop, we have one, and it's useful for people because we have people from different places coming in. They use it, I think, to encrypt traffic back and forth to Shreveport too, don't they? I think they do. I'm going to go with they do. I may be wrong, but that'd be a good use for it.